Yeah. All right, so buddy, get into the right class. Now go to class or I'll break your foot. All right, so Wednesday, September 4th, Buggy Pre-Lab. And then click on the link in that first sentence. And that takes you to this Desmos. So magic button time. This is a new feature of Desmos that they introduced partway through the year. When you've got a data set to plot, it might not be visible right away. Magic button over here. This is the zoom fit, this little magnifying glass. So hit that and see what happens. Previously, you would have had to go into the wrench tool and like guess at the x-axis range and the y-axis range. But now you hit this, boop, hey, there's my graph. Then we would have talked about this yesterday with the cacti and the pineapples. This is an inverse relationship. So the general form for that is y equals a over x. And when you type in y equals a over x, Desmos gives you the opportunity to put in a slider for the value of a here, our constant, right? And yeah, tune that, see what you get. What's the best number there, right? And then once you get your number, go ahead and throw that into the Pear Deck. Let's see where you land. Find the best number for A. Or the okayest. How about that? Best kind of stresses out kids at West High Best High. Where'd we land? Boop. Where's the Pear Deck? All right. Friends are thinking somewhere between 43 and 46. 44 looks to be the mean value right now. So let's try that. So I can either type that in directly or I can adjust the slider. And I think when you came in, did you have to change the max range here? No, it was already allowed you to go up to 100. That's sad. Oh, I wonder if I change mine, then whatever. We'll figure that out later. Initially, when you come in, let's see. Well, whatevs. Let's make this be 45-ish. Yeah, that looks all right. Mr. Harding said don't go through the dots. Yeah, but it's okay here. You're using a digital tool. We're trying to get the line as close as possible to as many dots as possible. Did we talk about units for this number yesterday? So have a think about that. Dimensionally, you've got, let's see, basic form of equation, y equals 45 over x. Y has the dimension centimeters. Then you've got no units presently on 45. X, width, that's going to have the unit centimeters. What goes in place of this question mark so that I have the same thing to the left and right of the equal sign? Run that by your neighbor real quick. So what goes in here? What goes in the question mark here to give me the same units? Go ahead and type that into the Pear Deck if you would. All right, let's see here. Survey says, looks like most folks think centimeters squared. Okay, so if we put in centimeters squared, that's centimeters times centimeters. That's going to cancel out with the bottom, and I've got centimeters upstairs both sides. So the units on 45, that should be centimeters squared. We didn't talk about the meaning of that number at all yesterday? Maybe we weren't completely done talking with the cacti friends. All right. The 45 centimeters squared, that's our constant. It's not the slope. The graph has a slope that is changing. That's our constant. Okay? And so what's the significance of that? What type of thing has the units centimeters squared or inches squared or feet squared or miles squared? So what type of a thing are we talking about here? And maybe what's an example of something that would be measured in feet squared or square miles or something?
Other than Spanish paragraph.
Other than Spanish paragraphs. You could use that as one of your examples, but cats are so Iowa. Area, so like acres. Acres? Is it acres squared? What is an acre?
A square mile.
Is it?
I don't know.
Seems kind of small to be a square mile. My parents' farm is like 40 acres. It's pretty small. Is it like a hectare? No, that's probably a smaller division of an acre. I don't know. Area, property area, or surface area of a two-dimensional object, an area of land, fields of corn. Way to fit the stereotype there. All right, area. So area. So that type of thing relates to area, okay? So what I'm trying to model with this is a process we're going to have to do this year. Use the units on the constant to help you interpret its meaning. Go back to the bubble that you put on here, which was to include the things that were held constant about your data set. So if you didn't do the Spanish paragraph lab, this is what it looked like. Got all these paragraphs, and can't pinch them up. But it's like, oh, there's certainty. Oh, de escapado lector. De escapado lector. Oh, okay. So, cosas está mismo. It's all the same paragraph. So that's what they say in the bubble here. Number of words within the paragraph stays constant. Okay? The word count of each paragraph is constant. So the suggestion is then that 45 centimeters squared represents, what about that? Have a conversation with your neighbor really quick. Don't worry about this typing thing that we're having an online class in person. So talk to your neighbor. 45 centimeters squared is what about that? Okay, and we can see it right here on the pineapple. The area of each paragraph, 44 centimeters squared. ¿Es verdad or no?
You kind of want to add something to that.
Ooh, cool. Let me allow you the pear deck. Boop. All right. So, yeah, what is 45 centimeters squared or 44 centimeters squared or 47 centimeters squared of this? Pop it into the pear deck. Approximate area of each Spanish paragraph, represent constant product of height and width. Word count plus all the spaces in the paragraph. And that's the long story shortish, yeah? So all those paragraphs roughly take up the same area. Oh, sorry, I didn't have the screen down there. It's hard for you to read. Roughly, all those paragraphs have roughly the same area. And that's what that is. Like, if you just rearrange that equation, height times width, that's area. But we made it more complicated using physics. So, all right. This is an inverse relationship. The reason that I wanted you to all have this open is because something that you'll get asked to do from time to time with graphs and physics is to linearize them. So I wanted to talk about that process with Desmos a little bit and hope that it will maybe help you out a little bit on down the road, say on the AP exam if they were to ask you to do something like that. So let me pop a page open here in period 5. Yeah, that's cool. Boop. Linearizing graphs. Get a little picture of this thing. Hey, that's you guys. What's he doing with our picture on the internet? All right. So there's the graph. So height equals 45 centimeters squared over width. We want the linear form of that, okay? Linear equation. So y equals mx plus b, because that's really simple to deal with. So basically what we got to do is look at this thing and kind of turn it into that, okay? So height on the y, yeah, that's pretty straightforward, okay. What is m to this thing? 45 centimeters squared. And then x, well, in this case, it's 1 over the width, okay? So 45 over the width, aka 45 times 1 over the width, plus b. What's the significance of that? So let's go back into the Desmos and see what happens if we have it plot that for the graph. So I'm going to go to the plus. I'm adding an expression. And I'm going to give it a data set to plot instead of what it's doing right now. What it's doing right now is this. It's just doing x1, comma, y1. Not y12, dude. All right. x1, comma, y1. That's producing the thing that we have there. Okay, right? So those are the blue dots that just showed up. I want it to plot not the width, but 1 over the width. So I'm going to tell it to plot 1 over x1. And then that happened. What the what? Looks pretty vertical, Mr. Harding. Well, look at the data column. Okay, 1 over x1. Your biggest number is going to be whatever you get when you do 1 over 2.5. That's kind of small, yeah? So let's change the range here. I can do that with the wrench tool. We don't ever go negative horizontally, so I'm going to make the minimum x-axis value 0. And I'm going to make the biggest x-axis value, boy, it looks like we can get away with 0.5. Okay? Ooh, I got one other thing I need to do here. This is no longer width. Oh, what happened there, Mr. Harding? This is no longer width. So I need to retitle this axis. This is now 1 over width. Now it's labeled appropriately. Ooh, no, it's not. So the unit is now 1 over centimeters. Now I'm good. And it looks pretty linear. Okay, so we kind of used the original form of the equation to guide what the linear form would look like. So now I can go up here. I can add an item. I can add in an expression. Y equals mx plus b. And I do want to add sliders for all those things. And I'm going to guess that b is 0. Let's see what I get for the slope. Oh, it's going to be more than 10, Mr. Harding. So this is where I was talking about earlier. I was confusing myself. Click on the 10, and you can make that as big as you need to be. Well, how big are we going to need it to be here? We would anticipate the slope is going to be less than 100. I can do that. And now I just tune this, okay? So see what kind of a value you get for the slope there. Check that out. And then, yeah, lo and behold, yeah, it's that same number. It's that same constant. The units would still be centimeters squared for that. But if you're asked to produce the linear version of a relationship, you're not going to plot height versus width. You're going to plot height versus 1 over width. That's what the original graph suggests if it's a hyperbola. And I will throw this at you in various forms this year. You don't need to really necessarily know the physics behind the data set, as long as you can figure out what the basic form of the raw graph is. You should be able to get yourself to the linear form of it, okay? I've got this chart in here that I've included, kind of the most common mathematical models, okay? And we saw some of these already. Y equals B, well, that was the age versus shoe size graph. Y equals mx plus B, y equals mx. We're going to encounter a lot of y equals mx squared. We'll encounter some y squared equals mx, and then this thing, which is y equals m times 1 over x. And this chart includes the modification required to linearize the graph, okay? So that's there for you. All right, and this video exists too, and I'll link back to it later when we need it. So that's how to linearize a graph. So we're good. On the pineapples, and the cacti. So does that just leave alum? And lilies. Where did I put the lilies? Where did I put the lilies? Colson, you're wearing a Cubs hat. Pick a board, either board here. Go ahead and whip the sock at it. Which one do you want? South. Right on. All right, Aloe, pop on up here and talk to us about this one. All right, Aloe, what relationship, if any, exists between
height and wingspan?
Okay.
So we found that wingspan correlates pretty closely to your height. So your wingspan will probably be about the same as your height.
And we, as you can see, the line is linear. There's no intercept because the wingspan technically can't be 0, because otherwise it wouldn't exist. And then the slope is almost 1, and then the best fit line is wingspan equals 1.1 times height minus 18.9.
All right, Prayer Deck is open. Questions and concerns for this group?
Did you measure people that had changes in height? No.
So that's just the line.
That was just the best fit line.
That's why we put points there, so you can see where our data was. We could cut it off here.
Okay, got a question for you back here, which is where does the 18.9 come from?
So when we plug our points into Desmos, that was our line of best fit. So if it was a perfect world, then it wouldn't exist. Or since our slope kind of suggests that wingspans are generally a little bigger, that kind of accounts for it.
What range of heights was collected?
For the most part, it was between about 160 centimeters and 190 centimeters. But 195 centimeters.
talking like number of heights collected, it's like 7.
7 degrees. Close.
Yeah.
Okay. Interpretation of the slope.
So as height goes up 1, wingspan goes up 1.1.
And then Grace has kind of said that already, and they're pretty tightly related. If somebody's got a height of 2 meters, you're going to anticipate the wingspan could be darn close to
2 meters.
2 meters, or just a smidge over. Okay. Wondering if you think the results are different using a younger age group. The height and wingspan go at different rates.
That would be interesting to test, actually.
Yeah.
You would think that your wingspan would grow at the same proportion as your body, but
Are there aspects of youngins that are not proportional? Babies kind of have big heads, right?
Yes.
Yeah. When does that go away?
Sometimes
Sometimes
never.
Sometimes never. Fair enough. Okay. But I like this type of thing as well, like supposing opportunities for further study. So that's good lines. Let's see if we're getting some other stuff. Ooh. Speaking of which, how about could the data differ between females and males?
I mean, we only measured media for a female, but it really didn't differ like drastically. It was about the same. My wingspan was a little bigger than mine.
Based on one lady person.
Yeah, I mean, there's not like a huge amount of difference to begin with. So.
And anybody else? Tim size was 7, right? You said that already. Things that were the same, like no shoes.
Measured
Yeah.
only humans.
That to me is kind of the one that is kind of like the areas of the paragraph in the last one. Like for humans, pretty close to 1-to-1 for wingspan and height. I don't know if we talked about this previously. Suggest a species where that might not be the case.
Birds. Any
Oh.
kind of bird.
Birds, okay. I heard that's birders initially. So birds, right? Condola eagles, that sort of thing, might be different there. Orangutans, okay, that might be different. So it's important that we measure humans specifically. Not give that much. Okay. I think that's about the time. Thanks, Aloe. Pick who you would like. Oh yeah, clap for Aloe. Clap for Aloe. Who do you want to hear from next?
We don't really have a choice.
All right. The illusion of free will. We're going to hear from the lilies.
Where do you want to?
Just down is fine. I'm going to share these with the parents tonight. They'll be really impressed, maybe just as they.
Wait, parents?
Yeah, back to school. Nobody told you? Oh my gosh.
Where you're going?
Happy to. All right. Lilies, I'm going to try to finally eat my lunch while you talk about what relationship, if any, exists between.
Circumference and diameter.
Okay. Do that.
So we have a linear graph. Its a-intercept is 0. And we found our slope to be 3.2 centimeters, which ended up being our equation for circumference, which is 3.2 times the diameter.
So basically what we did was we have like a bunch of different weights, and then we just measured them each from the center of each weight to the side with like a meter stick or whatever we use. And then we assumed pi was 3.14, and then we just used the formula pi times diameter to find circumference, and then we just plotted the circumference against the diameter, and we found linear relationship.
All right. Questions and concerns on that? Bruh.
Your boys still answer that question. Well, okay, well, I'm probably gonna call you now.
we have to clap before that?
How would you have done this if you didn't? Oops, sorry. How would you have done this if you didn't assume pi? AKA, done it the way it asked you to.
You could have like measured like do the like the row structure, like measured circles around the circle and then divided by that.
That's what I was hoping for. Because you didn't measure, you calculated. Sad face. Okay. And so that's part of the issue here. There's an assumption. There's an assumption of pi. Somebody else had brought up that question as well, like, how do you know the circle's truly a circle? And then that would have got at this thing, which is, there we go. Y is 3.2 and pi is known as 3.14. So the point that I was trying to get at had to do with measurement. And how I want you people in here to deal with numbers. So because I made every group do this same lab in regular physics. These are from your other AP periods. These are where they measured it, and they got a slope of 3.3. Here they got a slope of 3.4. There they got a slope of 2.6. Why use that when pi usually known as 3.14? What's the point I'm trying to get at here? Run it by your hand real quick. All right. So, can you long story short this for me? We got 3.3, we got 3.4, we got 2.6. So the groups have measured it. What does that tell us? Can you say it without using the words human error? Go ahead and type it into the Desmos there. I'll give you the question. Use human error. I'm going to march down to the guidance office. Right. So a couple of things back here. So imprecise measurement across the groups. Hard to measure the diameter when you don't know where the center is. To what extent do we agree with that? It's a tough
It's like little dots, like little dots on the grids that show sort of centimeters. So it wasn't too difficult to understand.
Regardless, if you're measuring the diameter, you know that's going to be at what point of the circle? Longest or widest, right? So if you kind of jot things around, you can kind of figure out where the longest way across the circle is. provided that it's a circle. Okay, somebody had that up here as well. How do you know it's a circle? Kind of gets into this a little bit. Don't assume something to be true without testing. That scientific mindset. I'm not meaning to be like harsh on this group, but it'd be more scientific if we go into it without the assumption of 3.14 and then demonstrate that on the back end. Okay. But going into it with the assumption of 3.14, well, that's the only conclusion we ever arrive at. Okay. We want to try to go into it without that assumption. Okay. And then yeah, that's where it shakes out. So 3.3, 3.4, 2.6. When I had them average it out in regular physics, it averages out to like 3. Okay. And then you're just like, why did I spend all that time with Mr. Norton memorizing pi to 30 digits? And we're just going to use 3 in here, Mr. Harding. Well, I got news for you kids. If you go on to really fancy physics like cosmology or astrophysics, guess what they use for pi? 1. Okay? Because that precision is unnecessary at that scale. So all you really need to know in here is that the circumference is roughly 3 times the diameter of a circle. That'll be enough to get us through, at least close enough for government work to what it is when we do circular motion later on here. Okay? So that's what side of that. Did we clap for the Lily yet? Thank you, Lily. All right, cool. I think that's that for that, right? So if you're good to go, could you double check your lab sheet? Make sure you've got units and labels on axes and all that good stuff. And the equation's written in the proper format, not with the variables y or x, but with the actual things. Go ahead and put that in the right basket then if you would, please. Right back, so towards the lab area. One per person, hopefully, because we're practicing learning how to do individual graphics. Other things to be mindful of. Intro to Mastering, due Thursday. Okay? 11:59 p.m. I shorted up YouTube browsing about some of the stuff that's out there, because some of them you don't need to know how to do until later in the year, so I'm just going to hold on on making you learn how to do those things for later on in the year. So it's about 6 minutes shorter now. It's like 43 minutes long or something like that. Okay? So it should be more doable for you. So do get started on that. I had 3 people that were all the way done, so they'll get like a bonus point for having completed the extra question. And then that means we're ready to go ahead and start the first kind of real unit of the year. So I consulted the sorting hacks. I need you in groups of 2 for this unit. And so here's what it spit back at me. So if you want to go ahead and move so you're by the person that you're with, because you're just going to be groups of 2 here. So Don't blame me, blame the sorting hat.
No.
Can you read that, Oakley? You can see that him and Grace and Raymond are the Ravenclaws. Nicole and Nathan are the Gryffindors. Coulson and Don are the Slytherins. Alex and Julian are the moms.
That doesn't matter. I think it's like a student-run organization against. What is it?
What even is that?
So just get up, move around, move around.
It's an anti-professional. The thing really short. And then they go and get.
Raymond, I'm with
Well,
you.
Dumbledore's army is the best of everything. Of all houses. No, Dumbledore's army selects like non-dumb.
And try not to sit in front row.
That's what they're doing. Like, let me do this. This rock and another rock. I'm so courageous.
Just your name. That's yours, yeah.
Like the one with like the wrist face to the door.
All right. Thank you, buddy. So this new unit. There, put it all right, check this out. Ooh, there we go. Never mind. Check.
Okay, no. Literally, why aren't we gonna let the learn? If it falls off the table, then it needs to touch them off.
The illusion of free will time.
Okay, so in the Pear Deck, hey, what'd you notice? So let's see what our friends noticed here. We'll just do everything at once. Kept veering to the right. Car was leaning slightly to the right at all times, going wherever it was going until he made it go on a different path. Sounds like parenting. Car drove with a slight tilt to the right. Could have driven off the table numerous times. Speed is constant. Car slowly drove at an angle at which it would fall off the table if not for a correction by a human. Oh, you think I'm a human? Car wasn't going perfectly straight. Could fluctuate left and right. Kept drifting to the right. Constant speed, ideally one direction. Constant speed. Car needed direction to stay on the course. Car didn't go in a perfect straight line. Had to hit the car with a ruler to the straight line. The same speed. Vehicle moved. Its soft speed was constant. Car is blue. Kept going to the right. Failed to complete obstacle course. Okay. So, yeah, common themes there. Tending to veer to the right. Okay. And then also constant speed. What's meant by that? Run that by your real quick. Constant speed, what does that mean about it?
Yeah, it's not like
Direction with. For the purpose of business. going at conference. It wasn't constant. Because whenever you hit it, no matter what, it's not accelerating. And if you're going already.
How about this? I'm hearing some debate about whether the speed was constant. What could we, and I'm going to be really specific because of that circle group. I don't want calculations. I want to know what can we measure directly to help identify if that is the case. Direct measurements, not things that would get input into a calculator. What are we going to measure directly? We want to see if the speed is constant. So like not calculating the circumference, but actually measuring it with the rope, okay? Apply that here. What are the things you would measure directly to try to establish whether or not the speed is constant? Some of you apparently have radar guns on your cell phones. What are you going to measure directly? Ooh, people are adding themselves. Okay. All right, so distance traveled at a certain period of time, distance car moves a certain interval of time, distance traveled during a certain amount of time, time to travel different distances, divide the counter space into even intervals and time for each interval, okay? So the long story short, the common things that we're seeing there, distance and time, okay? And so we'll talk about that a little bit specifically. Why not speed directly? What would we need to measure speed directly? Radar gun, right? We'd have to sneak over to the old UI Athletic parking lot thing and swoop the radar gun out of the passenger seat of the cop car that's parked there. We're not going to do that, though, okay? So, like, carefully run away going 25 miles an hour so we don't get pulled over. But distance and time, those are reasonable enough things to measure directly. Is it 1:43 and we're out of here in a minute? Oh, man. All right. So we'll talk a little bit more about that tomorrow. Okay? Don't forget, intro to mastering. Don't forget, back to school night for parents tonight. Later.